So yesterday, we talked about some visual data analysis tools, such as a bar graph, right? Bar graph, which is when you have a qualitative variable here, a qualitative, that means, if I can spell it, which means it's a variable, okay? Qualitative. So for example, ABC, and then on the y-axis, you have frequency, which is a quantitative value. It's gonna be a number. Then you get something like this. That's a bar graph. Versus a histogram. What's the difference between a bar graph and a histogram?
Both sides are quantitative.
Yeah, exactly. Both sides are quantitative. And again, on the y-axis, you have frequency. On the x-axis, you're going to have some numbers. Now here, the order matters. In the bar graph, you could have written C first, B first, it doesn't matter. But here, the smallest number comes first. So let's say this is 0. And then the next number, 1, the next number, 2. Right? It's like this. Histogram can be skewed. You can either get something like this, like a pyramid. This is, and then you just draw a line over it. This is called symmetrical. No tail is winning, they're both even. Or you can get a staircase going up like this. Where's the tail for this guy? Is it to the left or to the right?
The left.
Yeah, this is called skewed to the left. And then you can get something like this, staircase going down. That would be skewed. The tail is on the right. This will be skewed to the right. Yeah. What else did we do? We also talked about pie charts. So let's say we have ABC. We have frequency 1, 2, 3. What's summation F gonna be? Remember how to find summation F? You just add up all the F. It's 6, right? And then to find a pie chart, you need to come up with the relative frequency, RF. The formula for relative frequency is just you take your frequency, you divide it by the total sum of frequencies. So the first one, it's going to be 1 over 6. The next one, it's going to be 2 over 6. That's 1 over 3. You can write that as a decimal if you would like. The last one is going to be 3 over 6, which is 0.5. Once you find your relative frequencies, you need to find the angle. And the formula for angle is that you take a relative frequency, you multiply it by 360. The first one here is going to be 60. The next one's going to be 120. The next one's going to be 180. Start with a circle. Line up your protector horizontally like this, with the center being here. 60 degrees is going to be somewhere there. That's going to be your A. Next, line up your protector here. The next one is 120. This is 90. 120 will be somewhere here. That's going to be your B. And C is automatically going to be the remaining one, 180. So that is a pie chart. Cool? Next, we kind of started talking about mean and median. Let's go back into those guys. What do they want? All these want the mean. Okay, whatever. Mean is pretty simple. Median is the one that's a little bit more confusing. So here is a question. They've asked us to find the median. All right. Let's say they also asked us to find the mean. Look at this. Mean is very simple. Mean, the symbol for mean is average. It's X bar. And the formula is summation X divided by N. What does summation X mean for us? What do we add up?
The numbers.
Yep, you add up all the 7 numbers they've given us. 312 plus 257 plus 421 plus 289 plus 526 plus 374 plus 497. What's your N value?
7.
7. So divide this by 7. That gives us our mean, which is the average. Now, median is a little bit more trickier. Median represents where the data is cut exactly in half. This one's tricky. There's 2 cases for this. When N is odd, and when n is even? Look at this, when n is odd. For example, you have 1, 4, 8, 9, 22, right? What's our n value here? 5, yeah? Which number is exactly in the middle?
8.
Yeah, exactly. So when n is odd, you don't really even need to do any maths. The median is gonna be 8. But when n is even, for example, like this, 1, 2, 3, 4, there's no one number that's in the middle. The middle part is in between these two numbers, yeah? What's in the middle between 2 and 3?
2.5.
Exactly, 2.5. So here, n is 7, so n is odd, right? This one's a little bit trickier. What do you think the median is?
289.
Yeah, see, that's a trick question because 289 cannot be the median. 289 is the smallest, the second smallest number here. It's because,
do you put them in order?
Yeah, you have to put them in ascending order. So that means from the smallest number to the largest number. First comes 257, 289, 312, 374, 421, 497, 526. This is called a data array. When you go from the smallest number to the largest number, and from here it's going to be easy to find the median because it's going to be the fourth number. It's because the fourth number has 3 numbers to the right and 3 numbers to the left. So your median is going to be 374. Okay? So median is a number that's exactly in the middle. It's the same thing, right? They've made our life a little bit difficult by not putting this in an array, but we're going to cheat and we're going to put this in an array. So what's our n value? 1, 2, 3, 6, 9, 12. N is 12. So that means your median is not going to be a number that you just take from this. It's going to be in the middle of 2 different numbers. We're going to cut this in half. 12 means there's going to be 6 numbers to the left and 6 numbers to the right there. What's our median here?
12.5.
Yeah, 12.5. The next thing, we talked about median and mean. The next thing is mode. Mode is probably the easiest number. Mode is the number that comes up the most, has the highest occurrence. You don't need to put the data in an array for the mode. It's only for median. You also don't need to put it for mean. Look at this. Which number comes up the most?
74.
That's it. Your mode is 74. Graphically, on a histogram, your mode will be the one that has the highest frequency. You see, whatever this number is, 1, 2, 3, 4, 5, 2 would be your mode because it comes up the most. Highest occurrence. Very simple idea. What about here? They've given us 5 different numbers. The question is to find the mode. Any ideas? Which number comes up the most? It's a trick question.
They're different numbers.
Yeah, no one is winning, right? No one number is winning. There's no mode. Everything only comes up once. Mode is the number that occurs the most frequent. None of them in this case. There's no mode. Okay, they all have equal heights on a histogram. Cool? Then you can also have something like multiple modes, like for example in here. In here you have 2 19s, 2 22s, 2 21s, and 2 22s. Okay, that's already been done. Notice how these number occur more than, like, for example, 27 only comes up once, 25 only comes up once, right? But these numbers, they come up multiple times, or they come up at least twice. Okay, they are winning. If you would draw this out, you're gonna get some of numbers only come once, but then some numbers are gonna come up twice. You see this? Something like that?
Mm-hmm.
So in this case, this is gonna be a multi-mode scenario when you have a bunch of different modes. You can have bimodal, which means 2 modes. You can have tri, which means 3, okay? So this one is gonna be a trimodal because we have 3 different numbers that comes up twice. So all these are gonna be your modes. 21, 22, and 19. All of them are your modes. And this is a trimodal situation where they come up more than the other guys. Here's another key idea. On a histogram, they will ask you sometimes to identify where the mean, median, and mode is. If something is symmetrical like this, there's 3 cases. This is case 1. If something is symmetrical, then you see here, whatever this is, the peak, where the derivative is 0, right? Nothing to do with derivatives,
Mm-hmm.
but we know when the derivative is 0, the slope of the tangent line is 0. That point there, whatever that x value is, let's say it's 2, your mean is gonna be 2, your median is gonna be 2, and your mode is gonna be 2. They're all gonna be the same numbers when something is symmetrical. That's case 1. Case 2 is something that's skewed to the left like this, okay? Something is skewed to the left. I always like to look at the peak because peak is where the mode is. Here, this is the peak, yeah?
Mm-hmm.
This is the mode. And it always goes in this order. It's always gonna be mean, median, mode. Okay, mean, median, mode. Or it's gonna be mode, median, mean. Median is always gonna be in the middle. So if in this case, if something is skewed to the left, that means we're gonna follow this rubric because mode comes at the end. This is gonna be your mean. And this is going to be your median. Because it always follows mean, median, mode. Your median can't be over here because that's not 50% of the data. Median is gonna be exactly in the middle, right? So it's gonna be somewhere here. It's gonna follow this trend, mean, median, mode. Now the third case, as you can imagine, is gonna be something that's skewed to the right. Something like this. What is this called?
The mode.
The mode, right? Again, it's gonna follow this now. Median is always gonna be in the middle. The next comes the median. The next comes the mean. Mode, median, mean, okay?
Mm-hmm.
So in this case, your mean is gonna be bigger than your median. By bigger, I mean you're not looking at the frequencies. You're looking at what the actual x value is. In this case, let's say your mode is 2, median is 2, mode is 1, mean is 3. Mean is bigger than your median. You look at the x values. Over here, your mean is smaller than your median, right? Again, you're looking at the x values, not the frequencies. The x values that corresponds to your mean is less than the x value that corresponds to the median. Does this make sense?
Mm-hmm.
Left skew, right skew. Mean, median, mode. I mean, we can just really quickly do this. Ignore the mean because mean is very simple. You just add them up, you divide by n. Again, they've not put this in an array for us, so it's gonna be a little bit trickier. Which number is the smallest one in 3.9?
0.
No, because there's negative numbers.
Oh, -9.
-9, and then you get -7, 0, 2, 5, 7, 10, 16. So what's your n? 1, 2, 3, 4. Your n is 8, right? Cut this in half. 4 to the left, 4 to the right. Which number is in the middle?
3.5.
Yeah. What about the mode? Is there one?
No.
No. 3.10. Let's put that in an array. Which number comes first? First 3.10.
-16.
Yeah, -16, -1, 8. Oh, 0, they're tricking us. 0, 0, 8, 14, 18. Cut it in half. What's your median?
Is it 8?
Yeah, it's 8. Again, you just find the average between the two numbers. You get 16 over 2, which is an 8. What about the mode?
8.
8, right? Let me quickly find the mean of this. -16 plus -1 plus 8 plus 8 plus 14 plus 18 divided by 1, 2, 3, 6. So the mean is 5.6. So it's not symmetrical. I was hoping it would be symmetrical when mean, median, mode is the same, but it's not the case in this case. Everything else is exactly the same. You just find mean, median, mode, right? Let's look at the next number. The next thing. It's called range. Very simple. Range means the biggest number minus the smallest number. Here they've given us a bunch of numbers. The range is gonna be this, 267,000 minus 49,000. That's it. Largest minus smallest. The biggest one minus the smallest one. All right, let's look at the next idea here, which is gonna be very important, called the variance. Now, variance and standard deviation, they're related. In fact, variance is just the standard deviation squared. What this means is how far apart is your data? How far apart are your numbers? You see this? 1, 2, 8, 14. They're not equally spaced out, right? So standard deviation kind of gives us an average of how far they're spread out, okay? And usually in real life, the lower your standard deviation is also, you can think of it as kind of like the error. You want to have it equally spaced out, okay? And have it equally. So the higher you're spacing out, the worse the data is. You want to have something that's equally spaced out, but that's next to impossible in real life situations. So in that case, we want to try and reduce the standard deviation. We can't eliminate it completely, but we can try and reduce it. There's going to be some formulas for this that we're going to use. It looks kind of weird, but don't worry about it. I'm looking for a question. Right. It'll be something like this. So they've given us 4 numbers, 82, 95, 67, and 92. And the question will ask you, find the variance or the standard deviation. You see this squared? If something is squared, that's your variance, okay? In fact, this guy right now, this letter is the Greek letter sigma, like you've seen pi. This is sigma, like this. Sigma squared represents the population variance. So it's for the whole population. Whereas S squared represents the sample variance, okay? Can you give me like 1 minute? There's someone at the door.
Okay.
All right, I'm back. Sorry about that. So yeah, sigma squared, population variance. S squared, sample variance, okay?
Mhm.
If they only give you S or sigma, S will be the sample. S stands for sample. It'll be the sample standard deviation. Sigma stands for the population standard deviation. Look at this. Let's say S is 3. The question will ask you, what's the sample variance? Very easy. You just square it. It's going to be 9. Sigma is 2. That's the population standard deviation. What would be the population variance?
4.
4, right? Very simple. Square one, get the other. Sometimes they'll give you this. To find this, you simply square root it. But how do you actually find these things? So they've given us 2 formulas up there. They're very similar. The only difference between them is that here you divide it by n, whereas here you take 1 away from n. It's because sample is, again, it's not the population. Again, it goes back to this question here. We're going to use the sample to approximate what the population would actually look like, yeah?
Mhm.
So look at this. Let's say you have a nice number, maybe 20. 20 over 5 is a 4, yeah? Whereas 20 over, if you take 1 away from this, look at this, 5 minus 1, you get 20 over 4, it's a 5. So what the sample does is it accounts for the fact that it's only dependent on a smaller sample size. So it actually gives you a bigger variance, okay? It's kind of like it corrects itself. It overcompensates, that's what it does. So when you take 1 away, you're dividing by a smaller number, you're gonna get a larger number. Sample overcompensates for the fact that you're only using a small number to approximate for everything else. So how do you actually find these? Let's look at the formulas. So it uses something called x minus, you see this mu? This is called, it looks like an u, but again, it's a Greek letter mu. That's the population mean. This x bar, we've seen this before, that's your sample mean. If you look at this question, they've given us a sample data set, yeah? Sample of 4 students. The funny thing is, you can also have a population of 4 students. It's kind of weird. Let's say there's some city in some part in some country, okay? Let's say in that city, there's a school and 4 students go to that school. That's considered a population because there's only 4 students that go to that school to begin with. Whereas, let's say 20 students go to that school, we take 4 of them, that's going to be a sample. So a population doesn't mean it has to be an astronomically big number, okay? It just means it's just everything. You need to account for everything. So if there's only 4 kids going to that school, that is the population in that case. So this is a sample question. We're going to follow this rubric. Mu and sigma, it's almost exactly the same thing. The formula is the same. Mu is sigma x divided by capital N, whereas x bar is sigma x divided by small n, where n is the entire population, whereas here n is the sample size. So for us, we're going to use the sample formula. So x bar is going to be summation x divided by n. What's our n? 1, 2, 3, 4 numbers. What's going to be our summation x? How do we find that?
You add all the numbers?
Yeah, you add all the 4 numbers. You're going to get 336, yeah? Divided by 4, you get 84. So that's going to be step number 1. Again, we're trying to find the standard deviation or the variance. Once you have one of them, the other one is pretty simple to find. You just square it. Step 1, find x bar. Now, if you look at the formula, we're looking at this. It uses summation x minus x bar squared. Which one do we do first? Do we do the square thing first or do we do the summation first? What do you
The
think?
summation.
So here you would do the square first and you would add them up. So it's gonna look something like this. So I'm gonna write them down. Our X values are 82, 95, 67, and 92. We need to find X minus X bar. So that means 82 minus 84, -2. 95 minus 84, 11. 67 minus 84, 7, -70. 92 minus 84, 8. You're first gonna find X minus X bar. Next, you just square that. So you get 4, 121, 289, yeah, 289, 64, okay, like that. So we have X minus X bar squared. And then finally, you plug it into that formula. Look at this. S squared is gonna be X minus X bar squared 4. Now the summation. Summation just means you just add everything up here. So it's gonna be 4 plus 121 plus 289 plus 64 on the numerator. That's sigma X minus X bar squared divided by 4 minus 1, like that. This is gonna be a nice number. 478 divided by 3. No, it's not a nice number, but you get 159.33 recurring. That is the sample variance. If they asked you for population variance in this question, very, very simple. The numerator is in fact going to be exactly the same. Sigma squared is going to be a summation X minus X bar. It's just going to be the exact same thing. You're going to get 478, but instead of dividing by 3, you're going to divide by a 4. So 478 divided by 4. And the population variance is always going to be less than the sample variance because this one overcompensates. If our sample variance is 159.33, what's going to be our sample standard deviation, which is S? How do you find S given S squared?
E square root.
Yeah, straight up square root. 159.33 recurring square root. You're going to get a sample variance of 6.31. And there we go. That's how you would find your standard deviation by using this formula, okay? So that means on average, the distance between all 4 of these numbers, you can see they're not the same, right? Here to here, the difference is 13. Here to here, the difference is what, 28? There to there, you see all these numbers are big. The differences between them are big. Whereas this one and this one, the difference is 3. On average, okay, on average, they're 6.31 units apart. Cool? So it basically tells you how far away the data set is from each other or one another. What did we find? So there's another formula. There's multiple ways you can find these two. We use this one here. They want us to use these guys. This is what I would use as well. They will both give you the same numbers, okay? They'll both give you the same numbers. Let's start using this. I think it's a little bit easier because you don't need to make that extra column for X minus mu squared. On a formula sheet, I think both of them will be given to you, but this one is a little bit more popular, I guess, because it's quicker. So they've given us 5 numbers. What do they want? Find the variance and standard deviation. I had a question for you. It doesn't really say anything, but do you think this is a sample or do you think this is a population? What do you think? Are these companies, is this a sample data set or is this a population data set?
A sample?
A sample, right? There's no way there's only 5 companies in the world. Do they use this as a sample? They do, yeah. Right? Sometimes you have to, they won't tell you outright. Just think about it, right? There's one more company, Apple, you can think like straight up. There's no way there's only 5 companies that exist in the world. So this has to be the sample data set. So all of these are your X values, okay? So that means sample, we're gonna use this formula here. Look at what it needs. It needs summation X whole squared. So for this, do we find summation X first or do we find X squared first?
Summation X?
Yeah, summation X just means the sum of everything here. So it's gonna be 75 plus 107 plus 271 plus 138 plus 71. Summation X is 662. So this is in the bag, N is 4, this is in the bag, N minus 1 is also in the bag. The only thing we don't have is summation X squared. Which one do we do here first? Do we do summation X first or do we do X squared first?
X squared.
Yeah, so all these are your X values. You need to find summation X squared, which means you square all of them and then you add them up like this. Like that. So you get 75 squared plus 107 squared plus 271 squared plus 138 squared plus 71 squared. So that gives me 114600. Now we can plug it into the formula. S squared is going to be summation X squared, 114600 minus summation X, which was 662 squared, divided by 5, divided by 5 minus 1. Do you have a calculator on you? Because plugging this is also a skill. Try plugging this in. Do this bit first, and whatever that gives you, divide that by 4.
I got 26,951.2.
For the numerator? Okay, now divide that by 4.
6,737.8.
There we go. That is your sample variance, okay? Sample variance. To find the standard deviation, you simply square root that number. So that is going to be 82.08. So what does this actually mean for us? So this is going to be like a bar graph, right? You see qualitative here? The order doesn't really matter, but so the first one is 75. The next one is 107. The next one is like 271. The next one is like 138. The next one is, again, it's a 71. See, the average distance between these is 82.08. That's what it gives us, the variance and the standard deviation. Let's go back to the formula here. In fact, we can look at everything here. Question for you. Can these guys ever be negative?
No.
No, you're squaring something, right? You have a number, you're squaring it. These guys will never be negative. If these guys will never be negative, can these guys ever be negative? Turns out it won't be, okay? Because you're always going to be taking the square root of a positive number. Because these guys are always going to be positive. You're always going to be taking the square root of a positive number. Hence, it'll never be negative. Cool?
Yeah.
Okay, whatever. We've done this a few times now. Have you heard of the word statistics? Which is basically what
Yes.
data analysis is. So what exactly is statistics? Statistics is when you take a sample, okay, this is the concept of when you take a sample and you use this to make predictions about the entire population. Okay? Statistics always refers to a sample. Whereas there's something called a parameter. This is your mu, basically. This is your population. Statistics is for samples. Parameters is for the population. And it's very hard to gather data for the population. That's why almost always we use a sample to make predictions. There's a whole courses that you can do. You can get an entire degree on just this one topic called sampling. I'm just going to give you a quick overview of some sampling techniques. Let's say you have 10 numbers. It doesn't matter, whatever the numbers are. The easiest sampling method is called a simple random sampling. Let's say our n is 10, okay? Let's say our population is 10. Let's say we want to pick a sample size of 3, okay? We just want 3 out of the 10. Simple random sampling. What this does is you just close your eyes and you blindly pick 3 numbers randomly, okay? Funny thing is, no, it's okay. We don't want to. I was thinking we should do something, but it's okay. So you just take 3 numbers blindly. Doesn't matter. You can do 3, 4, 6. You can have 1, 2, 3. Doesn't matter. This is you just take 3 numbers blindly in a random fashion. Another technique you can use. This one's the cheapest and the easiest. Cheapest and easiest doesn't always produce the best data. Next one, what you can do is, I'm trying to think. You can do something called stratified random sampling. So this one, what this one does is this one creates something called stratas, which is just a funny word for groups. Okay. So let's say we want to put the numbers 1, 2 randomly. Again, this is done randomly. Groups are made randomly. You put these 3 numbers in one group. And let's say you pick 3, 5, 6 in another group. And let's say you pick 7, 8, 9, 10 in another group. Notice how 3 of these are in 3 different stratas, 3 different groups. And then what you do is you pick, because we're looking for 3 ends, yeah? You pick 1 from here, you pick another number from here, and you pick another number from here. Now this one is almost always going to be better than a simple random sampling. It's because you're giving each group a representation. If you do a simple random, right? Notice we don't have a number above 7. Like these guys didn't get picked. These didn't get represented. And this is not meant to be intentional, okay? You can unintentionally, this happens in real life as well, which is why we do like something like stratified random sampling, because you want every group to have a representation in the sample, yeah? Let's say we're making, we're trying to study the wages, okay? We're trying to study the wages of a city or whatever. And let's say these are the high income people. These are like the low income people, and these are in the middle. Now, if you pick a simple random sampling of 3, 4, 6, you didn't pick any of the high earning people, you'd make a conclusion that the wages are kind of in the middle, right? It's not very high, mid to low, because you're taking a sample of people in the middle and people in the low class, middle to low. Whereas if you pick a stratified random sampling, every group gets a representation. So this is always going to give you a better conclusion or a better result, okay? There's way more. This is just one or two, the main ones that we use in real life. There's 20, 30 of these that you can use. There's entire courses on this, which, I mean, this is going to be in university later down the line. If you pick a stat heavy course, what is a stat heavy course? Economics is a big one. But these days, statistics is very, very popular. Every course that you do, every program that you're in, you're always going to have to take one statistics course because, yeah, it's just that kind of a world that we live in right now. It's a very powerful tool, right? Like, for example, even if you study nursing, like I think your mom did, right? You need to pick a stats course because, again, it's a very powerful tool. You have a small sample that you can make predictions about the entire population. Nursing, you can go become a doctor, you need to do this. You want to become an engineer, you need to do this. You want to go into business, you need to do this, right? Everything, almost everything. You want to go into science courses, let's say you want to become a biologist, you need to do this. Every field every statistics is basically embedded in every field. It's, I think, one of the only topics, in fact, that is common in almost every degree program you'll see. You're going to see at least one statistics course. What's the next idea? All right, so everything we've done so far, they've just given us a bunch of numbers, yeah? They've just thrown numbers at us. This is called ungrouped, okay? You see, everything here is individual. They're independent of each other. This is called a ungrouped data set. Next thing we're going to look at is something called a grouped data set. A grouped means there's going to be classes. Look at this, 0 to 10, 10 to 20. When you don't know exactly, okay? This is, in fact, this is also used widely in real life because this gives us a better representation. Look at this. Instead of doing, like, let's say 0 to 10, there's 4. Let's say instead of doing, there's 0 zeros, there's 1 1, there's 2 2s, there's 1 3, there's like this. There's going to be like 50 bars here, right? There's going to be 50 bars. Instead of having 50 bars with a bunch of meaningless data in the middle, what we do is we group them up. So this one, you can kind of think of these as stratas. You group them up into one group. You group this into one group. These are actually called classes. 0 to 10 is a class, 10 to 20 is a class. It's better visualization, basically. Because having 50 bars with a bunch of small bars and a bunch of big bars and meaningless 0 bars in the middle, it doesn't help us. So we convert these into classes as they have done for us. The question is going to be the same. Find the mean, find the median, find the standard deviation. The formulas are going to be a little bit different for group data set. We can actually do the mean, median, and I also want to do the standard deviation. All right. So for a group data set, you'll see that you have a new variable now that we haven't seen before called M. You see that M? M is basically everywhere. We did see F. F is just the frequency. These are your F values. And we've seen this before. It's the number of data sets here. N would be 5. But we haven't seen this M guy, yeah? It's pretty easy. M is the midpoint of a class. So example, from 0 to 10, what's the midpoint?
5.
5, right? So to answer these questions, when you have something that have classes on them, you need to use this idea. So we're going to first find the M because almost every formula has the M value. So the first one's going to be 5. It's going to be 15. Looks like it's going up by 10 each time. 40 to 50 would be 45. Look at this formula here. Summation MF. What do we do first? Do we do M times F first, or do we add M and then multiply that by F? We're gonna do this first, okay? M times F. Look at the difference. Here, you would add them up first, okay? And then multiply by F. Whereas here, you're gonna multiply them and then add them later. So we need to multiply M with F, okay? So we're gonna make a new column here. We're gonna call this M times F. The first one's gonna be 20. The next one's gonna be, what's 15 times 9?
135.
Yeah, 15 times 10 minus 1, right? 9 is 10 minus 1. 150 minus 15, 135. What's 25 times 6? It's going to be 25 times 4 plus 25 times 2.
150.
150, right? 35 times 4 is 35 times 2 times 2. 70 times 2, 140. Again, you're going to have a calculator, but we're just going to train mental maths just for the sake of it, because it's a useful skill. A lot of these people these days, they're so used to plugging things in calculator, their mental math is not very good. So if you want to stand out, right? And eventually, if you do like an AP class or something, you're going to run into exams that don't allow you to use calculators. And that's when mental maths really comes into play. They don't give you like weird numbers. Like they're not going to ask you to do like 3319 times 6.83, or they might. You never know, but they're not going to ask you something like this. It's usually going to be something like what's 90 times 11, right? It's going to be something like that. You can come up with it really quickly instead of having to do this. You remember this? Instead of having to do this, then it will save you a lot of time. Anyways, we have MF, right? So let's say the question's asking you, find the mean, find the sample mean of this data set, of this grouped data set. It's grouped, it's because there's classes on them. There's a lower bound, this is called the lower bound, and these are called the upper bounds. So let's find the mean, or we're gonna find the sample mean. We're gonna assume these are samples. So sample mean is X bar equals summation MF divided by N, right? Summation MF is simply the sum of this entire column. So it's going to be 20 plus 135 plus 150 plus 140 plus 90. 535 is your summation MF. You divide this by what? What's our N? How many data sets do we have? How many numbers?
5.
5. So you have 535 divided by 5. It's going to be 27, like that. Cool? Next, let's find the population standard deviation, for which we have to use this formula at the bottom. Let's see what it uses. It uses n minus 1. We have this in the bag. It'll just be 4. We have n. We have summation mf whole squared. We already have this one as well, right? That's 535. But we don't have m squared f. Summation m squared f. Question for you. How do we do this? What do we do first?
M squared.
Okay, let's do m squared. So 25, 225, 625, and I don't know from 35. 35 squared is 1225. 45 squared is 2025. Okay, cool. Okay, we have m squared. What's next?
F.
We already have f, right? We're looking for m squared times f. Okay, summation m squared f means you first find m squared times f, and then you add them all up together. So our final column here is gonna be m squared times f. See, your m squared is 25. F is just the number of employees. This and everything here is f. It's going to be 25 times 4. It's going to be 100 for the first one. The next one is going to be 225 times 9. The next one is going to be 625 times 6. So that's what's that? That's not a nice number. It's 104.16. The next one is going to be 1225 times 4, 4900. The last one's going to be 4050. And then you add them up. Okay, look at this. Summation m squared f, you add them up. 100 plus 2025 plus 104.16 plus 4900 plus 4050. That's going to give us summation m squared f, 11179.16. Now we have everything. Let's just plug it in. So s squared is going to be summation this 11179.16 minus summation mf, which was 535 squared divided by 5 all over 4 minus 1, like that. Cool?
Mm-hmm.
I got a negative number, which is not possible. Something went wrong. Let me see. Minus 535. Did I add them up right? 79.16 minus 535 squared. Yep, one of our numbers is not right. Let's see which one was not right. I may have messed up the adding thing. 100 is good, 225 is good. Okay, this one was wrong, this one. Yeah, I know it was wrong because you can't have a negative number, yeah?
Mm-hmm.
This one was too small. Okay, I did this times this. I should have done this times this. Okay, that was my bad. So this number is actually 3750. So that means this number is 14825. So let's try that. 14825 minus 535 squared divided by 5. And divide that by this. What did they get? There we go. It's 135. They're finding the population variance. And again, the only difference between population variance in this is instead of dividing this by -1, yeah, you see this?
Mm-hmm.
You divide it by the entire thing. Okay, f was also wrong. F is the sum of this. Summation f is 25. So here n doesn't mean how many things there are. Here n means summation f. So anyways, the population variance that they found was 135.04. Cool.
Mm-hmm.
Let's do a quick exercise here. This is again gonna be a quick one. Let's say x is 1, 2, 3, 4, 5. Yeah.
Uh-huh.
Let's say y is 6, 7, 8, 9, 10. Summation x, summation y, summation xy, summation x squared times summation y squared, summation x squared y squared. These two are easy, right? You just add all of them up.
Mm-hmm.
So that will give you 6, 15 for this. And this one is what? 6 plus 7 plus 8 plus 9 plus 10. That is 40. How do you do summation xy? Which one do you do first? Do you add x's first and then multiply that by y, or do you multiply x and y and add them up?
You multiply x and
Yeah,
y.
you're going to multiply. So it's going to look like this. 1 times 6 plus 2 times 7, all the way down to 5 times 10, and you're adding everything up. What about summation x whole squared times summation y whole squared? What do we do here?
You do summation x and then summation y.
Yeah, we already have those numbers, right? So this one will be 15 squared times 40 squared. What about this one? What do you do first there? For this one, first you need to find x squares, okay?
Mm-hmm.
So that means you need to make a new column. It's going to be 1, 4, 9, 16, 25. These are your x squares. And then you need to find your y squares, which will be 36, 49, yada, yada. And then you multiply these two and add them up. So it's going to be 1 times 36 plus 4 times 49 plus 9 times 64, like that. So you're gonna do this first, you're gonna do this first, multiply them, and then finally add them up. Cool?
Yeah.
All right, let's call it a day. I'll see you next time. Have a nice week.
Okay, thank you.
Bye.